Lesson 2-1 practice. Let's make a box. Question 1. This question has two parts. First answer part A, then answer part B. Part A. A rectangular schoolyard is to be fenced in using the wall of the school for one side and 150 meters of fencing for the other three sides. The area A of X in square meters of the schoolyard is a function of the length X in meters of each of the sides perpendicular to the school wall. Which of the following is an expression for A of X? Okay, this could be, let's draw the wall of the school. And then that would mean this would be 150 meters of fencing, these three walls. These two sides are X. So the fence would be 150 minus 2X. Part B, complete the following statements. If X is 40, the area of the schoolyard is blank square meters. All right, so we selected D, that means X is 40. This would be 40 times 150 minus 2 times 40. 2 times 40 is 80. So we have 40 times 150 minus 80. That's 2,800 square meters. A reasonable domain for A in this context is, it would have to be greater than 0, or it would be negative, right? If this was 70, if X was 75, that would make this equal to 0. 2 times 75 is 150. 150 minus 150 is 0. So it would have to be less than 75, or be negative. Question 2. This question has two parts. First answer part A, then answer part B. Part A. Noah finds an expression for V of X that gives the volume of an open-top box in cubic inches in terms of the length X in inches of the cutout squares used to make it. This is the graph Noah gets if he allows X to take on any value between -1 and 5. Which of the following would be a more appropriate domain for Noah to use instead? You can see it starts out at 0 here, and then it's 0 somewhere around 2.5, and the maximum is somewhere between them. So it would be somewhere between 0 and 2.5. Part B, what is the approximate maximum volume for his box? Round to the nearest whole number. The maximum volume was about 15 cubic inches. Question 3. This question has two parts. First answer part A, then answer part B. May wants to make an open-top box by cutting out corners of a square piece of cardboard and folding up the sides. The cardboard is 10 centimeters by 10 centimeters. The volume, V of X, in cubic centimeters of the open-top box is a function of the side length X in centimeters of the square cutouts. Which of the following is an expression for V of X? So we would have to cut out the four sides, the four X corners. So 2 from the length, 2 from the width. So it has to be answer choice C. What is the volume of the box when X is 3? Okay, if we replace X with 3, 2 times 3 is 6. 10 minus 6 is 4. The same for the second factor. 2 times 3 is 6. 10 minus 6 is 4 times 3. So this would be 4 times 4 times 3. To do times, you do shift 8. It's 48 cubic centimeters. Question 4. The area of a pond covered by algae is 1/4 of a square meter on day 1, and it doubles each day. Complete the table. Write fractions in lowest terms using the form A over B if needed. Okay, so on day 1 it was 1/4. If I double 1/4, that would be 2 times 1 divided by 4, which is 2/4 or 1/2. If I double 1/2, that'd be 1 times 2 divided by 2, which is 1. If I double 1, 1 times 2 is 2. If I double 2, 2 times 2 is 4. And on the last day, 4 times 2 is 8. Question 5. Here's a table showing values of sequence P. You can see it starts out at 5,000, and then it looks like each time they divide by 10. 5,000 divided by 10 is 500. 500 divided by 10 is 50. 50 divided by 10 is 5. 5 divided by 10 is 0.5. Which of the following defines P recursively using function notation? All right, so each time, as I told you, they divided by 10. Dividing by 10 is the same as multiplying by 1/10. 1/10 is the same as 0.1. 1 divided by 10 is 1/10, which is the same as 0.1. So they take the previous number and multiply it by 0.1. Last question. This question has 2 parts. First answer part A, then answer part B. The table shows 2 sloth populations growing over time. Population 1 in thousands. You can see that it starts off at 90,000. Describe a pattern and how each population changed from one year to the next. Okay, you can see the second population goes down by 2 each time. So this would be what? 29 minus 2, 27, minus 2, 25, minus 2, 23. So population 2 decreased by 2,000 each year. Even though I said 2, it's in thousands. Population 1 decreased by blank percent each year. All right, to figure that out, we would have to divide, right? 76.5 divided by 90. 76.5 divided by 90. That is 85%. Let's look at the second one just to be sure. 65 divided by 76.5. 65 divided by 76.5. Also about 85%. If it 100 minus 85% means it decreased by 15% each year. All right, they want us to find the next 4 years, so we take 47 times 85%, which is times 0.85. 39.95. Looks like they're rounded to the tenths, so that would be 40.0. 40 times 0.85 is 34. 34 times 0.85, 28.9. We got 34.0 and what is it? 28.9. And finally, 28.9 times 0.85 is 24.56. We'll round that up to be 24.6. Again, it decreased by 15%, that's right, and 2,000 each year. These patterns continue for many years. Based on this information, fill in the extra rows in the table. Part B, which of the following shows on the same axes the graphs of the two populations over time, and then describe if when population 2 will ever equal population 1. Okay, so that starts off at 100. You can see it starts off at 90. 100, 85, 80. You can see that graph D is the only one that starts off at 90 for population 1. Okay, is this going down 2 each year? Yep, you can see it's going down approximately 2 each year. And then this one is, that was 90. The second value was 76.5. That looks about right. So when will the other one overtake that one? It looks like it's after year 8.